What's up, YouTube? Today we are talking about how to create a Turing machine in Bitwig's grid. I don't mean Turing like Turing band or Turing DJ. I mean Turing like Alan Turing, known as the father of computers or the father of artificial intelligence. Anyway, I think that the reason the Turing machine concept was named after Alan Turing is because it deals with memory and looking up array values to repeat signals. So for example, the way that we're going to be doing it in the grid uses a module called an array, which is quite similar to how computers store memory and look up memory. And this is a really interesting way, when kind of patched musically, to create melodies, rhythms, and all sorts of modulations. Also, I just want to give a quick shout out to the folks in the Bitwig Discord, because at first the array module is pretty confusing, and some of the folks over in the Bitwig Discord, specifically a user by the name of Arcane, helped me wrap my head around something that I seem to have been doing wrong in my original concept. So big shout out to the folks in the Bitwig Discord. If you guys are ever stuck with stuff, I find Discord is such a great place for troubleshooting these kinds of things, when you just have a quick question and need a quick answer. I know that there's a Kilohertz Discord, which is full of really good information, a Vital Discord, and several other Discords which I pop into now and again to get some info in case I'm trying to wrap my head around a certain concept or something like that. So anyway, big thanks to the folks in the Bitwig Discord for helping me with this one. So what I want to do is I want to talk about the concept of how to write data into the array module, how to read data from the array module, and then we're going to look at how to stack it up to create a pitch generator, a trigger generator, and a velocity generator. And each of these, hopefully, we'll be able to freeze. So we'll be able to randomize a pitch and then freeze it so that that pitch repeats indefinitely in time. And I want to hopefully be able to do this with triggers and with velocity as well. So it's a very basic concept, but like I said, at first it was a little bit confusing to wrap your head around because there was a little bit of information that was missing from the help. So hopefully this video will help those who are trying to understand the array module a little bit better and can't find that information online. So quickly, I just want to make an example of what this thing actually does. So I created it in the Bitwig Note grid so that I would be able to literally apply any VST after this and be able to generate MIDIs for that VST. So let's say, for example, I'm just going to add an instance of Vital over here and pull up a preset. And so the reason I did it in the note effects is so that I could use random generated MIDIs with any preset. I don't necessarily have to write a preset with randomization in mind. So I'm just going to pull up a random preset and let's see if we can get this working. So let me explain quickly what these modulators are doing so you can kind of get an idea of how this works before we actually dive in and create it, because it's going to be a little bit kind of mathematical and confusing for the first better half of this video, and we're probably only going to start getting musical results nearer the end. So I wanted to make an example for you now so that you don't lose interest. So essentially we have the P freeze, the T freeze, and the V freeze. I've basically split the Turing generators into three sections: P, T, and V. P is the pitch, T is the triggers, and V is the velocity. So we have P freeze, which essentially just records the buffer and loops that indefinitely. So when you turn the freeze off, it's just going to carry on indefinitely randomizing pitches. And same with the T for triggers and V for velocity. So if I turn the freeze off, notice how it's just going to keep randomizing. And when we hear something which we like, we press the freeze and it's going to loop that indefinitely. And I've also written in a reverse function. So this allows you to reverse the memory of the pitch or reverse the memory of the triggers. So for example, if you have like an ARP going upwards or doing a certain pattern, you can just press the button and it just literally just reverses the MIDI that's been recorded in. And then you've also got control over the size of the amount of steps, as well as the pitch range, and probability of the triggers. So once you've kind of got a rhythm, or once you've got a melody in mind, you can either shift it into a kind of more octave range, you can kind of make it longer so that it repeats less frequently, or you can make it shorter so that it's kind of more repetitive. And same with the T section, we've got a probability control. So we can kind of set it down to like 32%, and then only, for example, 30% of those, or 32% of those triggers are going to come through. However, there's something interesting that I've done here with the triggers where it's not actually randomizing. It's creating a sequence and it's recording that same sequence over and over again. So the probability is kind of baked into the recording. And again, I'm going to go through this later on in the video. Okay, so let's look at creating this from scratch. We're going to need to add a note grid. To make things a bit easier, we can actually just remove this input for now. There's a couple of things we can do. For example, if we want to quantize it and certain things to the input that's coming in, or offset it to the input that's coming in, I'll leave that choice up to you guys. I'm just kind of giving you the concept of kind of how the array works, and then you can kind of expand it as your needs are in your projects. So first thing I want to do is let's have a look at the array module over here. And what I want to do is I'm just going to put in an oscilloscope just so we can kind of read the outputs. Like I said, for the first kind of half of this video, most likely, we're not really going to be dealing with any kind of musical examples. We're kind of going to be more mathematical, so bear with me on this one. Yeah, let's set this to slow mode just so that it's a little bit easier to see the values coming out of the array. And what I want to do is let's set up a transport over here. Let's set this to 1/16. So what happens now, and I'm going to turn it to free running when stop off, so that this is going to be like the controller that's going to control whether the array is writing. It's going to control the cell value of the array, kind of like where in the array it's going to write that value to. And here, and then this module, the counter, this is the thing that was confusing me when I first tried to use the array, is that when I was sending it raw phase, check this out. So if you have a look at, let's just put this in here for now. So if we press play, nothing is happening. So with the note grid, we're actually going to have to set this voices to mono. And then it actually allows you to use note grid without any incoming MIDI data. Not quite sure why the mono setting does that, but yeah, that's what it does. So see here how the phase is like, let's see if we can actually zoom in a little bit more, like that. It's like a saw wave, right? But to actually read and write the cell values, we need to turn this into stepped data. So for example, if we send this trigger to the counter, notice how here it counts up to values of 8 and then resets back down to 0. So let's have a look and compare these two. So notice now how each time the phase runs through its cycle, the counter is counted one step forward, whereas before, the array values were reading every single phase. So this is an integral part of getting the array to work, and this is why I was a bit confused. You know, it doesn't say anything about why that is in the help. So yeah, that was a little bit confusing at first. So big thanks to Arcane for actually telling me about the counter module. Like I said, the counter module is integral for this patch. And another thing that you need to make sure of is that the step size of the counter is the same as the array size over here in the inspector. So now one thing that's actually really, really cool is you can modulate the inspector values, which is something I didn't actually realize at first. So if we put a modulator out over here, we can assign this to values in the inspector, which is pretty insane. So let's go here and put a value parameter into the modulator output, and this way we're creating a kind of a macro, right? And so here, let's set this array size to 2, let's set the counter to 2, and then if we get this to modulate these by the same amount, so let's just say, I'm just going to put them in manually, so let's just do this, and then you can actually click over here, and then you can punch in the exact values here. So let's say 10 and 10, because we want to maintain the array size and counter size the same every time. So we can just create a macro that's going to modulate them together. So notice here how when the value is down, notice how these steps are only stepping 1, 2, 1, 2, 1, 2, 1, 2, like a binary thing. And when we increase the value, we're getting more steps. So that's the first, I guess, logical breakthrough, which I had with setting up the array module, is this array size and counter system. Okay, that's step 1 sorted. Okay, so the next thing we want to create is some way of resetting the phase of the system, so that every time the transport starts, it goes back to the beginning of the cycle. So what we do is we put in a transport play module, and then we can put in a, we'll need a gate length just to make this a little bit shorter. Let's say 1 millisecond. And then here we set this to the retrigger. So watch this. If we stop and we play, every time it's going to reset to the beginning of the cycle. You see that? In fact, let's actually just make this a different color, just so it's easier to see in the scope. Huh? Why is that now not? Yeah, let's just do it like this. Okay, that's easier to see. So now when every time we start the playback, it's going to reset the cycle. Okay, next big breakthrough. So now let's look at creating values in the array. What I want to do is just duplicate this again, so we can actually read the values that are coming out. Let's just see if we can change this color. Yeah, okay, cool, that works. I think the phase is always purple. I think that's why. So with a Turing machine, I guess you could do this with LFOs or with any type of shapes, but I like to use randoms just because it kind of, it's obviously randomly generating a sequence for us, which we can then quantize and loop over and over again. And I think that's the beauty of this system. So the dice module in Bitwig is probably the easiest way of just quickly creating a random, and that works where every time it receives a gate input, it just randomly generates a value and spits that out of the output. So if we send this to this oscilloscope, we can just read what's happening here. Are you seeing that? So every time it triggers, it's creating a random value. Now what we want to do is we actually want to send this value into the array, into the input of the array. Yeah, what we can do is let's set the write phase to the same as the read phase. You can offset them to create weird like offset rhythms and stuff, but just to keep things simple, let's keep them at the same and still nothing. So now we need a way to be able to trigger whether it's recording values or not. And so here, for example, if we set this to the trigger input of the array, it's going to indefinitely receive those values, right? And always spit them out. So here what we can do is we could set up a system to enable this on and off. And the easiest way to do this is with a chance module, just here, in between that, right? And then we can just turn this to 0 and it'll stop recording, right? And then when we turn it up, it starts the recording and we turn it down again. And it replays what was being recorded. So now we have a fundamental issue in that I have the same problem as I had before figuring out the counter module. So what happens when we patch this counter into the read and write phase instead of just the raw phase? Then let's set this up to record values. Turn it down. And then it plays the values out. So the reason we're not seeing it when this is up is because obviously they're the same value as the value that we're reading from the randomizer. But then when we turn this off, it loops the value instead of bringing the value from the input. Are you guys understanding this? So now what we're doing is by modulating this on, we're creating a record buffer, and then turning it off, it loops that record buffer at the size of the array which we've set with this value over here. So we can actually just call this macro size, and then it'll display here in the grid as size. We can set up a button and set that to modulate this. And so that when we turn the button on, it creates the record buffer. So then let's set this to record. Okay, so let's look at how we would reverse the sequence. We can actually unplug this, and let's unplug this. And let's use the module which is called reverse. So what this does is it takes a phase input and literally just reverses the phase. So for sequences like this, it will actually just play it in reverse, which is pretty interesting. So here, what we can do is we could create a select module. And what this is going to do is take either the reverse or the forward and spit that into the read. Okay? And now what we can do is we set up a button to modulate that select module. As simple as that. So now this button just becomes a reverse. So let's record a buffer. Let's actually make it pretty small so we can kind of see the repeating pattern. Let's actually make this, and then let's just press reverse and see how it alters the signal. Like that. So cool. So cool. This is the basic engine of the Turing machine. So we take this concept and we just expand it to work in either the triggers department, which I'm going to get to a little bit later, the velocity department, and we can look at the pitch department. So what we can do here is like kind of once we've got all of this stuff set up, we don't need to actually be monitoring all of this. We could start adding the outputs for pitch. So just to keep things a little bit simpler, let's put all of these kind of macro controls to the side. I'm just going to do a bit of housekeeping here. So we can set it up like this, a nice small kind of square where we know where the controls are, and we have an output over here. Now, what we can do is let's duplicate this. Control C, Control D. Let's put in some labels here. Let's call this the triggers. The reason I'm putting it at the top is because the outputs here is at the top, just so that that'll make that a little bit easier. Here, let's set this to, and then let's set this to velocity. Okay, so for the pitch, let's set up a pitch quantize, and I want to set up an attenuate before the pitch quantize. And so we're going to go from this output into the attenuate, and that's going to allow us to create like a range of values, which we then quantize. So if, for example, let's put in like a minor scale over here, and then what we can do is we can just patch this directly into the MIDI output over here. Then if we press space, we'll need to record a buffer because we've duplicated it, and there's no triggers. Okay, so what we can do is we can actually just set up a transport to just trigger that while we're debugging like this. So notice how if we use a chance on the triggers, it doesn't actually repeat that sequence that we've kind of generated with the trigger section. We're going to get into that shortly of how to do that. But let's just quickly set up the velocity. So with this, it's literally as easy as, we don't generally quantize the velocity. So I would generally just send the attenuator into the velocity like this. And now we have, random velocity. Let's just see if this has a buffer recorded in. Okay, so with the triggers, how to set up a system which records a kind of generative or probabilistic sequence of triggers is to use a system where, for example, we do the same thing as we did with the pitch here. Let's just record in a buffer. I'm going to set this to 0 so we don't actually have anything, but we can see what's happening here. So we have a pattern of values, right? And then what we do is we determine a value at which any values above that point trigger, and we can use a greater than module to do that. So for example, let's put in this module over here. I actually want to use the value readout so we can see what exact values are coming here. Okay, so it's nothing above 1. So then what we can do is put in a value like this, send this And then anything that's greater than the value that we assign here will send the output. So check this. The more we turn it down, the longer or the more gate values it sends into the signal until all the way up, nothing. So it is inverted, but what we could do is we could just create a modulator to modulate it the other way around. Do you get what I'm saying? Yeah, then what we need to do is we need to somehow create a trigger from this gate that it's generating, right? Because it's not actually, this is not triggers. This is just gate values. So what we do is we use Boolean, which I explained in a previous video. Let's use the AND gate. And then what we do is we patch the transport. So this 1/16 in, this output, the gate, and then we send this to there, right? And now look, 16th triggers. So it's basically every time this and this are present, it generates a 16th trigger. And then this we send, let's just kill that, and we send that to the triggers there. And now it will repeat that trigger pattern indefinitely until we record a new buffer. So this idea is expandable to all of the MPE parameters in NodeFX as well. So potentially we could say Control-C, Control-V, and then we could make one for the brightness. So here, when we duplicate modulators, sometimes it duplicates, now it's sending to both of those attenuates rather than just the one, which is a little bit annoying. So here we can just remove the first one and just check, okay, yeah, cool. It's still only applying to the second one, and likewise. So it's good to just double check all of the modulators that you create in the patch. Just make sure that they're only sending to the ones that they're supposed to. Like these ones, only one set of steps and lengths. So here, it seems like it's duplicated 2 steps, which is a bit strange. I'm not quite sure why it did that. So let's just delete the first one. And let's just check in the array. Yeah, this one is modulating the array, which is good. Okay, cool. So let's call this brightness. And then let's duplicate it again. Timbre, double check the modulators. All good. See, it's weird. It's like sometimes it does it, sometimes it doesn't. Anyway. And this one we can call pan. And then just send this to here. So this won't work with Vital because a lot of the parameters here are like the pan and stuff are for Bitwig devices. Oh my gosh, that actually turned out way better than I thought it would. That is incredible. That is incredible. Let me know what you guys think in the comments. That's about all that we have time for today. I'm going to be uploading this note grid preset to my Patreon for all my $5 supporters. So if you want to know what that's all about, check out the link in the description. And yes, if you haven't yet, please consider subscribing to my channel and hitting that like button. If you like these very in-depth grid videos, let me know. Maybe I can do some more. Or if they're a little bit too complex, let me know too. Maybe I can kind of look at doing some slightly more basic stuff in the future. Anyway, let me know what you guys think in the comments. I will see you guys next time. Thanks for tuning in. Cheers.